Welcome, everyone, to today's Lunch and Learn Launch Your AI Project today with ApertureDB Multimodal AI Workflows. I'm going to go ahead and give everyone a couple of minutes to join. And while we're waiting, I would love to know where you're joining from and also just a quick shout out or hello. So if you can post your comments in the chat, that would be awesome. Ah, you're from Tampa, Seattle. Pretty awesome. Being from area. New York. So it seems like we have a good cross section. Parts of the state represented. We sort of have the West Coast, Seattle. Then we've got a little bit of the East with New Jersey, and then of course we have from the South joining. Um, okay, so we're going to go ahead and get started. My name is Deniece Moxy, and I'm the Director of Product Marketing at ApertureData. And I'm delighted that you've chosen to join our Lunch and Learn today. Before we get started, I have a few housekeeping details. A recording of this Lunch and Learn will be available on demand after the session. Um, we really love interactive sessions, so feel free to please post your questions in the chat window or any questions, comments, or anything that may resonate with you. We love to hear your feedback. And then finally, we have links to resources that will be followed up, that will be provided in follow-up emails. The agenda for today is pretty straightforward. First, I'll give you a overview of ApertureDB. And then the main event, we will have Luis Remis, CTO and co-founder of ApertureData, will have a deep dive into the functionality of ApertureDB Multimodal AI Workflows. And then finally, we will have questions and wrap up. Before we get started, today we have reached an exciting milestone. We have officially launched ApertureDB Multimodal AI Workflows on Product Hunt. A huge shout out to the ApertureData team for making this happen. At the end of the session, if you'd like to keep the conversation going, head over to Product Hunt and help support our launch. Your feedback is invaluable, and we truly appreciate your support in helping us reach this milestone. So now let's get started. As you know, managing multimodal data is hard. This is precisely why we built ApertureDB to simplify it. ApertureDB is a graph vector database purpose-built for multimodal AI. With ApertureDB, you can store application data, create knowledge graphs, and perform semantic searches using indexed embeddings. It allows you to manage various data types like text, images, videos, and audio through one unified query interface. We're often asked, how do you easily ingest data, create knowledge graph, and perform semantic searches using indexed embeddings? To answer that, we have created examples and along the way have turned these steps into reusable templates. And that is what we're launching today as ApertureDB Multimodal AI Workflows. Workflows make it incredibly easy to handle complex multimodal data processing in ApertureDB Cloud or any environment where you're building classic or generative AI apps and agent. For this launch, we have workflows for data ingestion, embedding generation, and object detection on faces and images, and the ability to launch a Jupyter Notebook. Today's launch of ApertureDB Multimodal AI Workflow is just the beginning. In the future, we will be releasing new workflows created by the Aperture Data team, as well as you, our valued customers and community. Stay tuned for upcoming RAG workflow for text. We also have a GitHub repo where you can check out the source code or build your own workflows. So now we are at the main event. I will hand it over to Remis, CTO and co-founder of ApertureData, for a deep dive into ApertureDB Multimodal AI Workflows functionality.
All right, great. Thanks, Deniece, for the intro. And yeah, we're very excited to show you this new functionality that we have added to our cloud service that allows you to process very easily all the information that you have on your ApertureDB instances. So let's get started. We're going to be doing essentially 4 things. The first part is going to be simply creating an ApertureDB instance on our cloud service. And then we're going to be ingesting some images that we have sitting on a S3 bucket, which is usually the starting point of many data science and analytics projects. We start with a bunch of images, very disorganized data on a S3 bucket, and we need to make sense out of that data somehow. So we're going to be going through that exercise and moving all that data into ApertureDB so that later we can process all of those images using the new feature and functionality that we have added to our cloud service, which is workflows. We're going to be running a few workflows and processing all that data stored on ApertureDB so that from that starting point of a lot of disorganized data, we can start creating our own data sets that we can use for follow-up tasks, right? So we're going to be doing those 4 things, and let's get started. As Deniece mentioned, if we make this interactive, it's going to be much more fun. So if you have any questions, just post them, and Deniece is going to interrupt in the middle with those questions, and we can cover those things. But the first step is very straightforward. We just go to ApertureData to our cloud service, and we can create an account very easily, or we can simply use your Google account to log in or create an account, right? So that's what I'm going to do. I'm going to continue with Google. And because I have my Google account, all of this is going to be loaded, and I'll be able to log in. So we have some resources here, a very rich documentation that you should definitely take a look at to understand more. But what we're going to focus today is on the creation of the instance and creation of workflows. So this is my account. It's empty. It doesn't have any ApertureDB instances or anything. And we have this new functionality that we're introducing, workflows, which is right here. But again, we don't have anything just set up yet. So the first step is going to be to create an ApertureDB instance. Very straightforward process. We just come here. We need to set up a name for the instance. I'm going to name my instance datasets because we're going to be, iterating and creating different datasets out of a source of data. I'm going to set up my admin password, which I'm not going to share with you. And we're just going to go with the defaults here running on Google, and we're going to go for a standard version. So you can select different cloud providers in different regions, and we have different options depending on the workload that you anticipate. And with that, that's it. We have our instance, our new instance of ApertureDB in creation process. This will take a few minutes, but after that, we will be able to connect to our ApertureDB instance and see what is the content. Of course, it will start empty, and we're going to start building from there. So we're going to come back here later. I guess we're with that done with the first part, where we create an ApertureDB instance that we're going to use as a starting point for our project. And we can move on into the next step, which is importing images that I have sitting on a S3 bucket, and how I can move that data into ApertureDB. Very straightforward, because we created a workflow for that. So here I have a bucket where I have a disorganized folder of a data set full of images. And let's see, for example, the content of one of those images looks like this. So this is part of the Coco data set. So many of these images are under the Creative Commons license. And but the starting point is that I have all of this data in a very disorganized manner sitting on an S3 bucket. So what we want is to move these images into ApertureDB so that we can start running processing on them and making sense of the information that is on those images. So I'm just gonna copy this name for later. This is the name of the bucket, and I also have a set of credentials that have access to the bucket that we're gonna be using very soon. So let me get this out of the way. And all right, here we see that we have our instance that it's up and running. And first of all, even before adding anything, let's connect to the instance. We can connect to the instance by clicking on the connect button, and we have a few options here on how you can connect to the database. We're gonna go with the URL here, which takes us to the web UI. So this is a web UI of the specific instance that I created, where I can see, the number of queries that are running and some basic information about the system. And more importantly, I can see the data. But right now, because the database is empty, all that we will see is nothingness, right? So here you will find all of the objects and connections that are sitting on ApertureDB. And ApertureDB exposes a graph model, so that's why we have objects and connections that represent nodes and edges on a graph. Nothing of that can be seen now because our database is empty, but that is the first thing that we're going to change. So what we want to do is import all of those images that are sitting on S3 into my newly created instance. And we can do that because we have a workflow that does exactly that. So I can go and create a new workflow by selecting the ingest from S3 workflow, which is going to do what we need. And what we need to provide is the name of the bucket, which is the one that we just copied here. And we need to provide some, credentials for S3 that need to have read and least permission to the buckets. Again, I'm not going to share all of my credentials with you, but that's it. Now we sit back and relax for a couple of minutes. And next thing that we should see is that all of these images that I had on that bucket should eventually be imported into ApertureDB, and that's going to be our starting point.
Luis, we have a question.
Yes.
Can we filter the objects to ingest by file type?
Yes. We can add options for that, and we can share links later to the actual implementation of that workflow, and you will see that it's very easy to make all of these changes and improvements. Yes.
Thank you.
Good. So our workflow is running. It has started. So we should already see some images coming into the database. Let's see where we are. And while we wait here, all right, we have some images already coming in. we'll see how the number keeps on increasing because those images are being moved into, copied into ApertureDB. There are no any metadata properties associated with the images, just the S3 URL that we have for reference. Yes.
So Luis, another question coming from Coffee Black AI. Does Aperture support attaching annotation data with images like Cocoa datasets you are importing?
Yes, actually we do, and that is another option that we have. So for the demo today, where we want to run processing on the images, we're starting with images, displaying images that have no metadata information, but we have support for storing all sorts of metadata information, and we actually have one workflow that will do the insertion of some of these data sets into ApertureDB for you to get started. We're going to be adding more data sets as in the coming months. All right. We're almost done. I think there are 5,000 images on the bucket, so we are done with that, and we can actually see, because on ApertureDB web UI we have a image search feature that allows you to visualize some of the images. So let's take a quick look of what we have here. All right, this is a public data set of a bunch of random images. So we have all sorts of images, people playing sports, animals, all sorts of things. But let's say that we actually want to detect people or we want to train a model where we need, in a situation where there will be people playing sports, right? Tennis, or I don't know, let's take this as an example. It would be ideal to start filtering the images and start getting some metadata information associated with those images. And that's exactly what workflows can help you. And what we are moving into is the third step. So now that we have ingested all of our images from an S3 bucket into ApertureDB, we are ready to start processing those images and discovering what is the content of them. By processing the images usually means running those images through a neural net, either to detect content, to detect objects, to do segmentation, all sorts of things. And that's what we're going to be doing next with our workflows. So the ingestion workflow finished, and we have all of our images already on ApertureDB. So we're going to just go ahead and create a new workflow that is going to run object detection on my images. Right? So this is very straightforward. We're going to be using the MobileNet model that we have as a default, but in the next coming weeks, we're going to be adding more models, and it's very straightforward to bring your own model and run this processing using your own model. For now, we're just going to go with MobileNet, and I'm just going to click Submit, and my new workflow of object detection is going to be running, which will generate bounding box information about the objects present on the images. And to explain that a little bit better, Deniece already mentioned this, but all of this work is all of the workflows are open source. So if you go to our public GitHub account and go to the workflows repo, you will see that the code is open source, and we have some nice explanations about how they work and how you can build your own workflows. And in particular, here is some explanation on the object detection workflow that we're running now. And here's a very nice picture that explains what's going on. We essentially have an application, which is the object detection application or workflow that will be running against an ApertureDB instance that we have. And what is going to happen is that first we're going to count. What the application is going to do is query ApertureDB so that we count and get a sense of how many images are in the database. And then on a loop is going to be running a query to retrieve images from ApertureDB and run those images through a neural net, in this case, the MobileNet. And with the result of that, of those bounding boxes that are generated, those bounding boxes are going to be pushed back into ApertureDB so that we can visualize them later. And using ApertureDB query language, we can select and start partitioning the original data set into something more useful. By the way, here is also the implementation of the workload itself, so you can go and take a look. And I guess the interesting thing that we do here is that we process all of those images using PyTorch. So there was a question about integration with other AI tools, and we have modules on our Python library that allows you to translate an ApertureDB query into the creation of a PyTorch dataset, right? And that is how this workflow works. All of this is things that you can copy and build your own workflows. All right, let's go back and see. We have the object detection workflow that it's running right now. And let's see whether or not they are bounding boxes showing up. Okay, so we have some bounding boxes objects showing up. These bounding boxes have a label and have the name of the model that is used and the confidence of that detection. All of this is information that we extract by running the image through a neural net. And as we keep refreshing, we will see how the number of bounding boxes keeps on increasing. And we can also see that we have connections here because the bounding boxes are represented in ApertureDB as a connection. So the bounding box is an object and the image is another object. And the way that we connect, and reference that certain bounding boxes correspond to certain images is through a connection on the graph. So in this case, we'll see that the same number of bounding boxes and the number of connections is there, right? What is more interesting here is that if we run this query again, we will probably see that our images already have some computed bounding boxes on them that we didn't have before. So we see person, bottle, person, all of these objects being detected. And same for animals and some sport related things. So we see the bounding boxes that are coming in, and actually just by running that processing and generating bounding boxes out of those images and getting their labels, we can start understanding what this data set is composed of and whether or not I can partition it to generate something that is more useful for my specific task. So one very easy thing that we can do is get a sense of the distribution of the labels of my data here. So I have a very short query. This is using ApertureDB query language, which we have very well documented on our documentation page. But essentially, we have here one of the commands, which is find bounding box, and we can group those bounding boxes based on the label. And we can query this information. And here we'll see that we have 32 bounding boxes that correspond to airplane. And let's see how many for person. So we have 1.6 K bounding boxes of person, right? So queries like these can tell us kind of like immediately some sense of what is the distribution of the labels and what is the distribution of the content that we have on this disorganized set of images. All right, we will still see some bounding boxes coming in, and that is the first part of the processing, right? So we started with nothing on our DB, then we added some images into our database, and now we're running some processing on those images. That processing so far has been only object detection, and we are generating bounding boxes as a result of that object detection to represent all of the objects on those images. But there is some other processing that we can do, like generate an embedding or a feature vector to every image on the DB. And that is very useful because if we have a feature vector or an embedding for every image on the DB, then we can do similarity search, and we can, using the built-in vector database that ApertureDB has, we can run similarity search queries. So that is another piece of processing that we can do, so that we can not only filter my images based on the labels of the object detection, but I can also filter my images based on their similarity with other set of images, and even something much nicer that I'm going to show you at the end. But let's get that rolling. That is very straightforward to do, because instead of running, is yet another workflow that we have here. We call it embedding extraction. Again, it's also open source, and this one is actually based on OpenAI Clip. So the embeddings that we generate are embeddings that have the particular characteristics that live on the same space as the natural language prompt describing the image, and that's something that we can use later for searches. But for now, let's just go with extracting those feature vectors or embeddings to all of the images. And here we describe a little bit what's going on. We're using Clip model from OpenAI. In particular, we're using the VIT v16 model. So I'll hit submit here, and the next thing we know is that we're gonna have embeddings generated for every image on the database, and we're gonna be using that for later. Those are gonna be the two main processing things that we're gonna be doing on the images. And then now that we have this image, these metadata images, this metadata information being generated for the images, we can start partitioning the data set and creating new data sets and filter based on all of this information that we are generating here. So let's do a little bit of that. So right now, the images don't have a lot of metadata information associated with them. We only have the original S3 link, that S3 URL, that it's just there for reference. And we also have a flag indicating whether or not the image has been run through a particular model, in this case, the object detection model. And soon enough, we will also see the same for the second workflow that we enabled, right? But let's say that we want to start grouping those images into specific data sets. So let's do that. One thing that we can do, I'm going to copy paste here a query that I'm going to explain a little bit. So I'm going to skip the details about the ApertureDB query language, but you will see that it's very straightforward to understand and get along with. And what we're going to be doing here is creating, out of all of the images that I have, let's say that I want to train a model where I need to detect people doing certain sports, right? So one thing that I can do is find all of those images that I have on my data set that have a person and, let's say, a ball or a tennis racket, right? So we can, because we have all of these bounding box information generated for the images, and we have all of the objects detected on the images, we can filter a subset of that data to generate a new data set. And the way that is done is, through our query language. You can build this, you can build Python applications, and actually I'm going to be showing you some Python applications at the end. But we have a functionality here in our web UI, which is the custom query that allows you to run these type of queries. I'm explaining this a little bit late because I already use it, but it's very straightforward. You just run using ApertureDB query language. You can run queries and see the result here. And the query that I'm going to run is find all of the bounding boxes that have a specific label. So it's a constraint search, and we're going to filter by the label person. And we're going to do the same, where we're going to find all of the bounding boxes where we find the tennis racket, which is another category that we had. And then we're going to find all of those images that are connected to those bounding boxes. This is done using a reference that we explained. This is a way of doing graph traversal. and it's the way to express the graph traversal query. We have more in our documentation explaining that, but that's essentially how this query is composed. We want to get all of the images that are connected to, let's say, both a person and a tennis racket, right? And we also want to update all of those images so that we generate a new, update all of those images and add a metadata property to those images indicating that those images belong to this newly created data set that we have here, which is person tennis racket, right? So I'm going to just go ahead and run this query, see what we get. All right, we only get 38. It's good enough. Let's see what that looks like. Now that we have updated some images, we will see that we have a new property called dataset that we should be able to use to filter now. So if we go to, let's just refresh this, and if we go to our image search here, and I will search the first 20 images that have that belong to the dataset person tennis racket. Let's see what we get. All right, fair enough. So we have, well, there's a strange detection there where this is detected as a tennis racket, but the rest look pretty good. We are filtering all of those images where we have people and tennis rackets on them, right? And it is that easy, right? Now that we have all this processed information about the images and their objects within, we can build, and filter and attach properties to those images to later query them and group them by, different things. In parallel, as we were looking at how we can build data sets using the newly generated information from the object detection, we also had this thing running, which was the embedding extraction that was computing feature vectors for all of the images on the DB. And let's see how that is looking. So actually, we've already seen it before. When the workflow started, it created a descriptor set, which is the index, the vector DB index that we have on ApertureDB, and we also have descriptors that are going to be associated to that index. On ApertureDB, we call them descriptors, but this is equivalent of saying embedding or vector, or So far, we have almost 2,000, a little bit over 2,000 embeddings. We should reach 5,000 because that is the total number of images. So this is still computing. We can see it in this number over here, that it should keep on increasing. And but something that we can probably already visualize on our web UI is that, let me just remove this filter and run this query again. We should already have the ability to filter based on similar images using those features. So let's take this image, for example, and you will see here that we have this search for similar objects button enabled because we have these embeddings computed for the image. And if we click on similar objects, we should already be finding images on the data set that have a similar content to our query original image, which is really great because now we can, search based on a sample image. So we take a sample image and we say we want to find all of the objects that are similar to this image, right? And we can group all of this image into a new data set that we can use, right? And what it's more is that because this detail that I was mentioning before, where the clip embeddings generated by this clip library from OpenAI, they put all of the image feature vector into the same space as the corresponding prompt, natural language prompt, meaning that we can, search based on a natural language query. Let's have a look at how we would do that. For that, we need some Python environment. So I'm going to use workflows again. Sorry, let me go to my account and workflows. And this time, what I'm going to do is create a Jupyter Lab workflow. This is just a Jupyter Lab option that we provide as part of our cloud service. And it just has, pre-installed packaging that it's useful to run queries and connect to the database. All I need to do is set up a password, which in this case is a password that I'm not going to share. And from this Jupyter Lab, I'm going to write some Python code so that we can run these queries using natural language to find and create data sets. So let's see where we are with the embeddings generation. Let me go to status and check this. So far, we have this number of embeddings. We should reach 5,000 anytime soon. And that means that we'll have embeddings generated for all of the images. In the meantime, our Jupyter Lab instance is starting. We should be ready in a few seconds, hopefully. But with that, we are essentially approaching the end, which is after having run so much processing on those images, I can partition that and create new data sets for any purpose, for training or for anything. So let's see. We're at 4.1 thousand embeddings. And we're just waiting for the Jupyter Lab to start. But the interesting thing is that at the same time, there are many things that are happening here. We have our object detection model that is running on all of the images on ApertureDB. We have our other embedding extraction workflow that is fetching the images, running them through the model, and generating all of those embeddings. And at the same time, in that processing, there is information being pushed into ApertureDB and being updated at the same time. And we have all of these workflows running from our cloud account. So let's give this a few more minutes. Jupyter Lab creation is taking a little bit longer than it usually does. I guess all the excitement about the launch and people trying things on the same clusters. Let's give it a few more minutes. And let's see how that goes. In any case, we have a plan B. We anticipated this. So let me execute some of our plan B, where I'm going to generate a Jupyter Lab on our internal testing infrastructure that no one has access to, so that it's not going to be affected by the load that we have right now. And let's give this a few more minutes. in the meantime, if there are any questions. I guess the other thing, the one detail that I see on one of the questions is on the embedding generation app. So let me show you that. We call it embedding extraction. And again, this is on our public repo, which contains all the code for our workflows. Deniece, you're muted.
Sorry about that. So there is a question about what happens to my S3 credentials after workflow is over.
Oh, great question. Yes. What is going to happen? So those credentials are removed, are only used within the lifetime of the workflow. And after the workflow is finished, those credentials are discarded and removed, because that workflow is run only once. And after the execution is completed, all of the things are thrown away. We will probably add in the near future a new workflow that will not be a thing that is going to run once, but rather maybe on a cron job it's going to run every day or every week, and in that case we'll have a different mechanism for storing the credentials in a more safe way. But right now what we do is just use them during that time and then discard them so that we don't keep them around.
We have a couple other questions. One is from Emmett. Can we schedule work flows?
Not right now, but that is one of the features that we have on our roadmap, because in many scenarios it's very useful to have these kind of like cron job structure things that runs once a day, once a week, and all that.
And we also have another question from Sonam. Is a GPU required to compute?
It is not required, and right now we are running most of the processing on CPUs. But if there are any specific requirements on speed, or especially if you have this at a large scale and you have to process a lot of images on CPU, it's going to take forever. So we can enable GPUs for maybe for some of the tiers that we have on our database, we can enable GPUs so that all of that processing can run faster. And another thing is that right now we're running one replica of the process, but in reality we have internal features that we're going to expose over time where you can launch multiple replicas of the same workload so that you have more compute running in parallel for all of these things. All right, and our Jupyter Lab, it's there, so I can just connect, and we're gonna run our last query that we have here very briefly. So what the original Jupyter Lab ships with not much, just a way to connect to the DB and some explanation. So we're using the ApertureDB Python package to do that. And here, to connect, you need to specify credentials, but because I don't want to share my password with you, I'm just gonna go here and generate a token that I'm gonna discard after we're done. And I'm gonna replace this with token, and I'm gonna pass my token here. And that should be all I need to connect to my database, right? This is the URL of the database. So we're good to go. I'm just gonna copy this and I'm gonna go here. We have a clip example. So here we describe some of the things that I already mentioned, where because we're generating these embeddings for the images in the same space as their natural language descriptions, we can run some queries based on natural language. So let me do that. To do that, it's very straightforward. All I need to do is import clip from OpenAI. This is OpenAI library, and I'm gonna simply load the model into the CPU because right now we only have a CPU, and we're gonna take a natural language query like a photo of a group of more than 2 people, and I'm gonna tokenize that using the clip library from OpenAI, and I'm gonna generate an embedding that I can use on ApertureDB to search for similar objects. So let me actually split this in 2 steps so that we can see it more clearly. The first step, we are just going to import things from OpenAI clip and run. Let's run that step. And at the end of this step, this is the first time that I ran this, so the BITB16 model is going to be downloaded only the first time, and I'm going to be good to go with the blobs. And the next thing I need to do is run a query into ApertureDB using our vector database, building vector database, and we're going to find the images that are associated with that embedding. So in this case, we're going to find a photo of a group of more than 2 people. So let's see what we get. All right. We're just getting 10 results for demonstration purposes. But look at that. Even without, without having any other information that the embeddings, the clip embeddings for the images, I can run these natural language queries where I can get photos of more than groups of people, and that can help us build a data set. How do we do it? In the same way that we did it before. Before we were doing it from the web UI, running a query using the objects that were detected on the image, and here we are doing it using similarity search. But what we can do is the same thing here. So here we are gonna, hit the wrong button. I'm gonna update image, and I'm gonna update the image corresponding to reference 2 in this case, which is the image, the result of the find image over there. And I am going to create a new property. So properties, data set, and this is gonna be a group of people data set, right? So I'm gonna just go ahead and run this query. Let's see what I did wrong. Oh, I need to run this again. And after we run that query, we should have updated some of the images that now we can come over here and filter based on the data set, right? So this is group of people that we name that data set. So we're going to retrieve the first 20 images of that. And now we have our data set of groups of people with their corresponding bounding boxes. So yeah, very interesting stuff right now, and more workflows to come. So we already have a few more. We have data ingestion for different data sets. We have a face detection one, and we will have more workflows related with language coming up soon as well. And I think that concludes that part. What we did is essentially start from 0 from scratch, creating an ApertureDB instance, importing images that we had on a S3 bucket, running processing on all of those images to extract bounding boxes for the different objects on the images, as well as generating embeddings or feature vectors for each of the images, and later on we create different data sets and group uh, portions of my original set of images into one data set that had only people playing tennis, and another data set that had a group of uh, you know more than two people. I guess that concludes this part, and yeah, happy to take any questions.
Thank you, Luis, for a very informative and great deep dive into ApertureDB multimodal AI workflows. Before continuing, I want to pause, see if there are any last minute questions. So one of the things that I teased in the beginning of this presentation was what we had, that today's launch was just the beginning, and we have our plans is to add additional workflows both from our customers as well as our valued community. Um, Before I continue, there is a question about could I load data from other locations like Drive, Google Cloud?
Yes, so we can get back to us and tell us specifically what we need, and we can. It's very easy for us to uh, add new workflows, and we can even walk you through on how you can experiment and build your own if you have like more specific requirements or things within your network and things like that. But these are very configurable and very easy uh, to adapt to new sources.
Okay, perfect. So for my final slide, I wanted to go ahead and share with you that you have access to resources. And here's a list of some of the resources that you will have access to. And once again, this lunch and learn will be recorded, and you'll receive also a copy of my slide deck. So if there are no other questions or comments, thank you very much for attending our Lunch and Learn. Launch your AI project today with ApertureDB. And don't forget to join the conversation on Product Hunt. Thank you, Luis. And
Thank you.
looking forward to seeing all of you at our next Lunch and Learn. Have a great day.